Hello, scholars. We're moving on. We're in chapter 5. This is lesson 7. I've actually been talking about it throughout the whole chapter because this is sort of where it all comes together. We've been doing congruent triangle theorems. We started with side angle side. Then we did side side side. Then we did HL, hypotenuse leg. Then we did angle side angle and angle angle side. So now that you have all of those triangle theorems under your belt, what we're going to do is use them in various situations and proofs so that you can prove any two triangles are the same. And if that's the case, then any of their corresponding parts will also be the same. So this is what we're going to go for. We're going to use congruent triangles in some real life situations. We're not going to be doing the constructions. We're not in, with the compass and straight edge. We're not live in person. If we were in the classroom, we would. For the meantime, you know these figures, congruent figures, and corresponding parts. I have 3 examples to show you, and let's go. So congruent triangles have congruent corresponding parts. So if you can prove that 2 triangles are congruent, then you know that their corresponding parts must be congruent as well. Here's one example.
Explain how you can use the given information to prove that the hang glider parts are congruent. Given angle 1 is congruent to angle 2 and angle RTQ is congruent to angle RTS, prove that segment QT is congruent to segment ST. Solution. If you can show that triangle QRT is congruent to triangle SRT, then you will know that segment QT is congruent to segment ST. First, copy the diagram and mark the given information. You are given that angle 1 is congruent to angle 2 and angle RTQ is congruent to angle RTS. Then mark the information that you can deduce. In this case, angle RQT and angle RST are supplementary to congruent angles. So angle RQT is congruent to angle RST by the congruent supplements theorem. Also, segment RT is congruent to segment RT by the reflexive property of congruence. Now, 2 angle pairs and a non-included side are congruent. So by the angle-angle side congruence theorem, triangle QRT is congruent to triangle SRT. Because corresponding parts of congruent triangles are congruent, segment QT is congruent to segment ST.
Because corresponding parts of congruent triangles are congruent is such a mouthful. Remember, we're going to abbreviate it as CPCTC, your best friend. Okay. We're going to do monitoring progress in class. Here's another example on how to use congruent triangles for measurement. This one is in your notes, so get those ready.
When you cannot easily measure a length directly, you can make conclusions about the length indirectly, usually by calculations based on known lengths. Use the following method to find the distance across a river from point N to point P. Place a stake at K on the near side so that segment NK is perpendicular to segment NP. Find M, the midpoint of segment NK. Locate the point L so that segment NK is perpendicular to segment KL and L, P, and M are collinear. Explain how this plan allows you to find the distance. Solution. Because segment NK is perpendicular to segment NP and segment NK is perpendicular to segment KL, angle N and angle K are congruent right angles. Because M is the midpoint of segment NK, segment NM is congruent to segment KM. The vertical angles, angle KML and angle NMP, are congruent by the vertical angles congruence theorem. Now, notice that 2 angles in the included side of triangle MLK are congruent to 2 angles in the included side of triangle MPN. So, triangle MLK is congruent to triangle MPN by the angle-side-angle congruence theorem. Then, because corresponding parts of congruent triangles are congruent, Segment KL is congruent to segment NP. So you can find the distance NP across the river by measuring segment KL.
I hope you followed all that. If not, back the video up, watch it again. Okay, we have one more example. This part is a proof, but you're going to be given the solution and then talking through. Usually when I go through it, I talk it through with you so we have a plan and then a solution. Okay, but the idea is that you'll write the plan for the proof, so you sort of have to do the proof first. Here we go.
Use the given information to write a plan for proof. Given angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, prove that triangle BCE is congruent to triangle DCE. Solution. In triangle BCE and triangle DCE, you know that angle 1 is congruent to angle 2 and segment CE is congruent to segment CE by the reflexive property of congruence. If you can show that segment CB is congruent to segment CD, then you can use the side-angle-side congruence theorem. To prove that segment CB is congruent to segment CD, you can first prove that triangle CBA is congruent to triangle CDA. You are given that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. Segment CA is congruent to segment CA by the reflexive property of congruence. Now, notice that two angles in the included side of triangle CBA are congruent to two angles in the included side of triangle CDA. So, you can use the angle-side-angle congruence theorem to prove that triangle CBA is congruent to triangle CDA. Because corresponding parts of congruent triangles are congruent, segment CB is congruent to segment CD. Plan for proof. Use the angle-side-angle congruence theorem to prove that triangle CBA is congruent to triangle CDA. Then state that segment CB is congruent to segment CD. Finally, use the side-angle-side congruence theorem to prove that triangle BCE is congruent to triangle DCE.
Remember, I've always told you every time you see something with connected sides, you're going to use it. So that's the first thing you do is you use CA in both triangles. So hopefully that makes sense to you. You make a plan. You see what you're given. And I really like the way they highlighted these green and yellow. So if you can't separate them that way, then redraw them on your paper so that you can and recognize that CA is congruent to CA. And then once you have the two triangles congruent, then you can say that CD is congruent to CB. So it's pretty straightforward. Those are the three examples. The rest of the chapter is about constructions, which, as I mentioned, we're actually not doing because we're not in person. And then there's proving constructions. Again, I didn't assign any of those problems for you. Now your BIM assignment will pop up and you can go do that. Remember, if you missed any parts, go ahead and re-watch the video. It's only a few minutes. Good luck, Geometry Rock Stars. You got this.